All right, I think I am live. I'm looking over at my other tab here and seeing my screen, so I guess that means I'm live. Hey to everyone who is here. This is my first time doing any sort of live coding project, so uh, probably there will be pauses and stutters and moments here while I'm not talking and figuring things out, but bear with me, and our end result will hopefully be something kind of cool. What I'm going to do here is create a implementation of Pong in the browser using HTML5 Canvas and JavaScript. If that's something that you're interested in learning how to do, follow along. It's targeted primarily at beginners, so if you know a bunch of JavaScript and HTML, this might be something you can figure out very easily, but it's interesting nonetheless if you like gaming and figuring out new APIs and stuff. Um, One thing I have learned as I've seen people kind of chatting in the Learn Programming Discord and from a lot of the messages I've seen is there seems to be a lot of questions along the lines of what framework should I learn next? What language should I learn next? A lot of people's learning focus is on making sure they are kind of like checking these boxes and kind of building up a list of proficiencies in different languages and APIs. This guide is focused a little bit more on a different approach that I think people would be well served to adopt as they are ramping up and trying to transition into a CS career. And that is to focus less on checking off these different technologies and more on learning how to like decompose the task you want to accomplish, and then after you know what you need, go out and search for different technologies. So that's why I'm starting with the first step here, which is to break down what we need to do to make a Pong game before I kind of like write any code or show you what technologies I'm going to use. Uh, Apologies, my dog's barking in the background. You could probably hear that. He will probably continue. Um, all right, so to make a game in Pong in the browser, let's just think for a moment like what would be the steps that you would need to accomplish. So step one, you need to figure out how to just draw stuff to the browser. That sounds really basic, but if you're coming from a background of having zero idea of how to make a game in the browser, that's going to be the first challenge. And when you're breaking these tests down, it's really important to break them down at a really minute level, because that's the level at which you're going to be able to find answers. If you go to Stack Overflow, and if any of you guys are learning programming, you might have experienced this, and you just post to Stack Overflow or any forum like, hey, I want to build this big app with a million features, and how do I do that? You're probably not going to get great responses because it's just way too big of a question for anyone to answer for you. So you've got to make sure you break things down into tiny little tasks that someone could answer quickly or that you can find in one piece of a documentation or in one guide. All right, so step two, once we know how to like just put something on the screen, let's say, how do I draw a ball and paddles? As I write these tasks, what's coming to mind, like, am I going to finish all of this in this stream? And I have no idea. I haven't rehearsed this. I was thinking I'd spend about an hour on this. If it's taking longer than that, I'll just call this part one and we'll do the rest of the steps after part one. All right, so step three, make the ball move. How would we do that? We're going to find out. Step four, make the ball bounce. The ball in Pong bounces off the walls. Step five, move the paddles with key inputs. That's definitely important for this to actually be a game. 6, make the balls bounce off the paddles. That's also important. And 7, Pong had like a scoreboard, and you want to add a point to it when somebody scores. So as you work through any sort of project, I mean, you're breaking down these tasks. You are going to, oh, that's a very good point in chat to increase the size. How do I do that? Preferences, settings. Good grief. Stuff I don't know how to do here. I opened it in 2 tabs and then closed it both. All right, default font size here probably is what this is. Can't edit it. This is the default. This is the user. That's why it works that way. Hey, look at that. Better? Bigger than that? Smaller? What do we think? Can we hear in chat? I'm just going to pop it one more. Why not? All right, there we go. That's a little bigger. Thank you, Misha. All right, so as you dig into each of these tasks, inevitably you are going to come up with more tasks. This is kind of like a recursive process. You're going to over and over again see like, okay, this thing that I thought that was 1 task is actually 5 tasks. Now I want to make a list of those tasks. That doesn't always have to be written. Sometimes it can just be mentally, but break these things down. Make sure because this is the real skill you have to exercise, and one of the like core parts of being an engineer is learning how to decompose a big problem into a small problem and then seek out the information you need for each of those small problems. Really, when you're on the job, often, I mean, you have to pick up new technologies really fast. No one's going to be like, oh, you don't have to do this work because you didn't put on your resume, you know that programming language. They're just going to like throw it to you and have you do it. And it really comes down to like not being an expert on every programming language, every web framework, every API. It's being able to like seek out the information you need. So, in the spirit of that, let's talk a little bit. How do we draw stuff to the browser? So if you have a little but not all that much understanding of how the browser works, you might know when you load your browser to a URL, what's happening is it is requesting to a server, sending a request to a certain endpoint on a server. And usually, if it's a web page, what is getting sent back is an HTML file along with a bunch of other stuff. But let's leave it at just a HTML file for now. An HTML file is just, you can think of it as just a plain text file that is structured in a specific way that tells the browser kind of the different elements that are a part of this web page document. So you can display a web page by requesting an HTML document from a server. You can also just save an HTML file right on your computer, double click it. It'll open up in your default browser and your browser knows what to do with it, which is to render that HTML document on the screen. So that's going to be how we're going to make Pong today. We're just going to create a new HTML file. Along the way, we're also going to create some JavaScript files. We'll get to that later. So step 1 here in the process, we're going to look up like what is the minimal set of HTML that your browser knows what to do with. Funnily enough, you could just open up a text file, type in hello world, save, let's see here, you're all going to see my documents file now, save something here, Pong.html, and all we put in here is the text hello world. Browsers are relatively smart. Double click that. It's like, oh, it's a piece of text. I know how to put that on the screen. That's not properly formatted HTML. Let's type into Google minimal proper HTML template. I don't know it off the top of my head. This is kind of the point I'd like to make. You know, constantly always just be going to Google, constantly be looking up new information. You don't need to remember all this stuff. Over time, you're going to build up an intuition as to where you can find these pieces of information, what information you see looks right or wrong, how to confirm whether or not it's right and wrong. This looks more or less right to me. Let's talk a little bit about what we're seeing. So what I'm deleting right now is script links to CSS and JavaScript, which we're not using right now. This is basically telling the browser a little bit of metadata about what I'm putting on the screen here. This is telling the browser, yeah, this is an HTML file. This is an attribute on the HTML tag telling the browser we're writing in English. This is describing which character set we're using. I'm not going to go into detail on character sets right now. This makes a title for your page, which among other things is like what appears right here. But again, just a little bit of metadata. So now to dig a little deeper into what HTML is, I said it is just a text file, and you're looking at this and thinking perhaps it doesn't look a lot like text. It's written in, well, it's what's called a markup language, and that's the ML of HTML. And a markup language refers to a type of document where you are marking up specific pieces of the content by surrounding it with these little guys, which we call tags. When we surround a piece of content with a tag, what we're saying to the browser is everything inside that tag, I'm giving you a little bit of information about it. So everything inside of the HTML tag is going to be our HTML document. Everything inside of our head tag, well, that tells the browser this stuff is metadata that you need to know about the document. Everything inside the title tag, well, we're telling the browser this is the title. So these tags can nest probably just about infinitely until you're run out of memory. I don't actually know if there's any hard limits there. But if you've ever looking at the source code of any complicated website, you'll see these documents are very big and they nest very deeply and are very complicated. For now, ours will be very simple. The body tag is also at the top level along with head, and it's simply, I'm sure it's more complicated than this, but for our purposes, we can think of it as this is the stuff we will see and that will go on the screen. So there are lots and lots of tags. As you get deeper into HTML, you will learn many of them. I encourage you not to try to absorb any resource that starts by trying to like exhaustively list them for you. There are many of them. They all work in complicated ways. Learning all of them might be akin to like learning the dictionary. It would be a lot of work. Target your goals to trying to accomplish something and pick up the tags you need in the process, and they will stick in your brain as you continue working. Sitting down and trying to memorize them in one sitting is a surefire way to burn out. Unfortunately, there are resources that are structured that way, not the best way to accomplish it. So now we have put something on the screen, and even better, this is proper HTML. We've put hello world into our body tag. The browser knows what this is. You'll notice it looks exactly the same. That's because the browser made some correct inferences about what we wanted it to do before. But this isn't our real goal. We don't want to put hello world on the screen. We want to put a small animated game on the screen. So the next question is, well, we know how to put different static elements here. If you do a little bit of Googling for HTML tags, you'll learn how to put text on the screen, images on the screen, links on the screen, tables, etc. What we want to do is put an animated game on the screen. So just to show you how like easy it is, once you break problems down to this scale to find out what you want to do, let's just Google like how to create a game in HTML. That's itself a really broad question. And we're not going to see the exact answer here, but as you scroll, you're going to see keywords that are going to guide your continued search. HTML5 Canvas and JavaScript game. Well, that sounds kind of like what we want to do. That's interesting. So let's just go ahead and drill our search in a little deeper. HTML5 and Canvas. What is that? We're going to find a million guides. One thing we're going to find in particular is the Mozilla web docs, which are a very good resource for learning how to do anything with JavaScript or HTML. But as we scroll through these results, we're going to see pretty quickly we're on the right track. This is what we want to do. We want to use the Canvas API to create our animated game. Sorry, I'm scrolling through my little notes here. If we spend some time reading the docs on Canvas, and if you're interested in it, I recommend you do. They're a little dry, but they link out to a bunch of guides, which can be super helpful. You're going to learn the way to structure your Canvas tag. Tags, they often look very similar. They open, they close. Some of them don't need a closing tag. Canvas is one of them. You can just do it like this. Even this guy perhaps is not necessary. I just told you that tags were about marking up stuff inside the tag. There's an exception to every rule. There are a handful of tags that do not require a closing tag or anything in them, and they kind of just tell the browser, put something here. And in this instance, what you're putting here is a Canvas object, element. So we're going to give our Canvas an ID attribute, and I'm going to tell you what that is in a little bit. We are going to set its width to 500 pixels, set its height to 300 pixels, and we're going to set a little bit of style here, which is how you set CSS attributes to any element. As you look at the API for Canvas, you will see a little bit about what attributes it cares about. You'll also see links to higher level elements probably. I mean, every element can take that renders on screen, divs, things like this can all take a width and a height. Often when you're doing anything with layout, and this is a common hang up with Canvas, you're not actually going to use the width and height attributes. You're going to apply it using CSS, which is the stuff that goes here in the style attribute. The reason I don't use CSS layout for Canvas is because Canvas, the actual internal code, needs to know the width and height it's rendering at. A default Canvas assumes that it renders at 300 by 300 pixels. If we don't tell it differently and we then set it to a different size using CSS, it will render at that size, but it will draw as though it is 300 by 300, and the stuff you draw will end up all stretched. So that's a concept that's deeper than a beginner needs to really understand. Just remember, if you're using Canvas and things look all stretched, make sure you're telling it its correct width and height. So we've added this Canvas tag here. We've given it a red background using CSS. We've told its width and height. We've set an ID on it using these attributes. Let's see what our screen looks like now. All right, a big old red square. Not terribly exciting. Let's make this a little bigger now that I think about it, since you're all watching a stream and not sitting with your eyes close to my screen like I am. So there's a big old red square. That is a great start. We have now learned how to put a canvas on the screen and made it visible by giving it a background color. So ultimately, this is not all we want to accomplish. So let's move on to the next step, which is actually drawing to our canvas instead of just putting our canvas on the screen. So as you read those Mozilla docs on what a canvas is, you're going to learn a canvas is an element that has a 2D graphics related API. So you can kind of make calls to this canvas to draw different shapes, different colors, what have you, to the canvas, and then it's going to appear on the screen. So HTML, this is a generalization, but it's a bit more static. People can do really cool stuff with CSS and JavaScript, but generally people are not making complicated animations directly in their HTML. A API like the one provided with Canvas allows for a much easier way to make animations. So let's step to our next step here. Sorry, scrolling down on my notes. So the way we interact with our canvas, it's not going to be anything in our HTML file. The HTML file describes to the browser what is the structure of the document, what are like the things here that it needs to put on the screen, the things it needs to know about, the different like components of this document. When you have dynamic stuff like responding to a button or performing an animation or maybe like showing a pop tip after a timer or responding to where the mouse is, anything along those lines happens through JavaScript. Uh, so how do we get JavaScript to run when we load our HTML file? Well, we go back up to the head tag. I told you this is kind of like metadata for your web page. And one piece of metadata is what are the different scripts we need to download and run when we load this HTML file. And the way we tell the browser that is with this script tag here. We use an attribute to tell it the type. And then we give it the source. And then we correctly format our tags. So we're telling this is a relative source. We're telling the browser where this Pong file is. Oh, gotta pay for my Sublime. On a web page, that's going to be, could be referencing a JavaScript file on another server, could be somewhere else in the directory tree. For us, it's just going to sit exactly in the same folder as we created our Pong HTML file. So let's go ahead and create a new file. We're going to call it Pong.js. We're going to save it directly in that same folder. Now when you double click your Pong.html file, it's going to load this file and it's going to run the script. So to kind of prove to ourselves that that is happening, we're going to do a little something like this. Hello world is like the default first message when you're learning programming stuff. You're going to see that a lot. If you're wondering why I keep typing in hello world. So let's now go back to our Pong.html. Double click. No, I must have done. Oh no, I didn't do anything wrong. It disappeared, but I got rid of the background color. So here's a handy thing. You can go to More Tools, Developer Tools, and this is the Developer Console in Chrome. We go to the Console tab, and look at that. Our code printed "Hello World." So the neat thing about JavaScript, and why I recommend it as a good beginner's programming language, is it runs right in the browser, and you've got these cool kind of like developer tools that you can use to interact with your JavaScript. It's got a debugger. You can step through the lines of your script. You can inspect the state of memory using this console right here, see what all your variables are set to. And your browser is something you're pretty familiar with using. It's kind of like having a really cool tool set just kind of given to you by default. But this is the console. This is where, when you print something to JavaScript console, where it goes. All right, so we've printed hello world here. What we wanted to actually do was figure out how to draw something to our canvas. So let's get rid of this. Let's scroll a little bit further to my notes. I'm going to do something real quick here that is you're not gonna understand until I explain it, but I will explain it. All right. All right, save that. Make sure I didn't do any typos anywhere. Let's reload. Boom, now we have a blue square. So how did that happen? I'm going to break down what I just wrote. So This little bit is perhaps the most confusing and also kind of not super related to what we're doing. But it's a good thing to just like keep in mind as you're doing JavaScript. Uh, you need to, if you're going to be grabbing elements off of the document, you need to make sure they already exist. And I'm not a JavaScript expert, so I've only really kind of come across this by experience. But if you have a big old document, it's going to run this script right away. Apparently that happens asynchronously, which means at the same time as it's loading the document content. It's possible that this line right here could run before this tag is implemented and initialized, I should say, as part of the document, and then we would not get a canvas and this all wouldn't work. So the window is a global property that's accessible to us in our JavaScript. If we add an event listener, we give it this key. We're telling the JavaScript engine, call this function that we're creating, an anonymous function here, just a bit of code that runs when this event occurs. DOM content loaded, you can probably guess from context here. That means that the DOM, which document object model, basically just all our elements in our document, they exist, they've loaded. You'll notice I added a ID attribute on our canvas when we created it right here. And that is so that we can use this function on the document, which is another global variable to grab our canvas element that we've created. So this is now getting in a little bit into the JavaScript nitty-gritty. Const, we've created a constant variable. That sounds a bit like a oxymoron. This is how you declare and assign a variable in JavaScript. That is a constant. Constant meaning I can't assign it to something else later. If I had done it like this, then it could be assigned to something else later. For now, we're going to use a const. We are assigning a variable named canvas, which is kind of just like a name we're giving to something that exists in memory that we can reference later to perform things on this object. And we are giving what exists when, or what is returned by this function that we're calling on the document, we're giving it the name canvas. Later on in our code, we can refer to it with the name canvas, which we do right here. So this grabs that element, assigns it to the canvas variable. Down here, we are making another variable, ctx context. This is a graphics context. When you're drawing things to canvas, you don't draw directly to the canvas object. That's the API doesn't work that way. Instead, you draw to something called a context. I presume the reason that works that way is because you can have different contexts perhaps on a canvas. The fact that we're passing in 2D implies to me maybe there's a 3D one. I don't know the answer to that question. But you know, you don't need to know everything about an API in order to use it. If you try to exhaustively read the docs, you will exhaust yourself. So next, how do we actually draw something to it? So you would explore these docs to figure out how to do that. You're looking at my code, so you're knowing, but you would see, okay, we've got a handy dandy little guide right here that shows basically what I've just shown you. You might wonder, all right, what is a context? You would scroll down in this documentation and you would find somewhere a reference to a context. You're going to tap into that API to figure out how it works, and you're going to see some more handy dandy guides because Mozilla is really good. And then you're going to see a reference here of all the different functions you can call on this. When you're interacting with a new API, a new class, it's great to skim this to get an idea of the capabilities of the class. You don't have to read it all. You don't have to memorize it. You know, you're coming to the docs with a specific goal in mind. Find the function you need and get out, or else you'll be in there forever. As you read this, what you're going to learn is that the way the API works is first you set, well, to draw like a full shape, you would set a fill style. We're setting it to blue. Think of this as what we're going to do next is we're going to draw a shape. Think of this as like the paint tool color that's going to get painted into that shape. And then we're going to provide it a rectangle. It's going to draw onto that rectangle. So we did blue. Now let's do black because the background of Pong is black. Don't need two of these open. Now we've drawn a black rectangle and it's looking a little bit more like Pong. So this is how we draw something a little boring, a basic shape to canvas. Now let's scroll a little bit further down in my document and find out how to draw something a little more interesting. Sorry, my notes go way deeper into JavaScript basics that we probably don't have time to fully cover, so now I'm doing a whole bunch of scrolling. All right, so I think we've answered the question, how do we draw anything to the browser? The answer there is, at a high level, you're going to use HTML. HTML is going to tell the browser, these are the different parts of this web page, the different elements. One of our elements is canvas. Now we've seen, well, how do we draw to canvas? Well, we've seen how to draw a rectangle to canvas, but at a high level, we know jump into the documentation for the canvas tag, drill down into the rendering context documentation, find the function we need to draw what it is that we need to draw, and that's going to like tell us how to or what functions we can call to accomplish what we'd like to on this object. So the next step was draw a ball and some paddles. So paddles will probably be easy with what we have learned so far. We just learned how to draw a rectangle, and paddles are just a rectangle. So let's figure out how to draw the circle first. That maybe will be a little bit more interesting. So we've just drawn a black square, and we know that the way we set the color for our shapes is with setting the fill style property on our context. So let's just go ahead and set it to white because the ball in Pong is white. As far as what this can be, I think this is going to support any keywords that CSS can support. You can very easily Google what all those different keywords are. You can also pass in a hexadecimal value that decodes into an RGB. You can Google how that all works too. But that's how people represent colors. Excuse me. So if we go to the documentation, we found that there was a fill rect function. We might hope that there is a fill circle function. That would do what we want to do here. We would be disappointed. There is not one. There is not a function for every shape. At a certain point, you have to start using a more complicated set of functions to describe the shapes yourself, because otherwise the API would be completely unwieldy. And the way you do that is by creating a path. And a path allows you to kind of describe to the context different starting points and stopping points as though you were kind of like drawing a pencil or holding a pencil and moving your hand. Excuse me. So the functions that relate to this are going to be things like add line to point, move to point, add curve. And you can kind of imagine like if someone put their pencil down on the paper when you said begin path, then all the functions you call after that point, you're telling them how to move that pencil. One of the functions that you can use here is the arc function. If you Google, again, I want to continue like showing how you'd figure this out on your own. HTML5, draw a circle. That is a task that's like small enough that you are going to find decent results. You're going to find out that the arc method is how you do that. The arc method, if you've got a little bit of geometry in your background, you know, I hope this is correct, but an arc is like a portion of a circle. So we're just going to tell it to draw an arc that is the whole circle. And the way we will do that is with this function right here. And then we are going to just do fill. We're not filling a rect this time, we're filling the path. I think this is going to be, math dot, this is how many radians are in a circle if you're not familiar. It's going to be too small because I doubled the size of my screen. Not too bad actually. That looks about the size a Pong ball should be. Maybe we'll move it up here. This is the XY coordinates of the center of the circle. I doubled those as well since I doubled the size of my canvas. There we go. Now we've got a big old circle right in the middle of our screen. Mission accomplished. We drew a ball. We can really quick draw some paddles too. Let's see here. Sorry, scrolling through my notes. Have to take a look somewhere real quick. Trying to do this how I did it before so that I have everything kind of matching. Just drop this at can't remember what wood I found was appropriate width and height for my paddles. So this is just drawing another rectangle. So this is something to cover real quick. X and Y coordinates within the canvas. The top left corner is 0, 0. As you move down and to the right, those numbers are going to grow. So you'll notice when we drew our background, we drew it at, this is the X coordinate of the origin, the Y coordinate of the origin, the width, and the height. So we drew it at starting at the top left, and then 1,000 pixels wide and 60 pixels or 600 pixels tall, and that's why I filled up the whole screen. Here we're going to draw these maybe 15 pixels wide. We'll see how that looks. Maybe that'll look good. Maybe it'll look too small. 30 pixels tall, and I'm putting one on the left side of the screen, one on the right side of the screen, and see if they look like two rectangles. All right, those are a little too short. Let's make them twice as tall. All right, there we go. Starting to look a little bit more like Pong. But still, this is not Pong, not even close. We've drawn some paddles to the screen. We have drawn a black background, but none of this is dynamic. None of this is animated. So now we need to move on to our next task, which is how do we make these balls move? And this is going to get into a new concept that is a little bit more related to game development, and that is creating a game loop or an animation loop. So there's not going to be an API on this graphics context that looks like take that rectangle I just drew and move it over there. I think they're probably, I don't know, maybe Flash worked that way. There are probably game frameworks that do work that way, but this is kind of like a low-level rendering API. All we're going to be doing here is just drawing stuff in real time. So if we want stuff to move, we actually have to clear everything off the screen and draw it again in the right place. Which means we need to have a function that runs over and over again to accomplish that. So we've talked a little bit about functions. We're using a function here in our event listener. You can think of a function just as a piece of code that is kind of grouped together that can be called. Called meaning run. We can run it over and over again. We can run it in response to a button click. We can call it from another place in code. Here we need to figure out how we're going to make this loop kind of just run infinitely over and over again at appropriate timing. So if you do a bit of Googling around, you might find there are things called timers in JavaScript. You can create a timer and pass it a function and say, run this function every 30 milliseconds, every 15 milliseconds, and you can make a game loop that way. It will have a bit of a limitation in that you can tell your browser to run something every millisecond. There's no guarantee that your browser is going to actually like run fast enough to do that. And the important part of a game loop is you need to know how much time has passed since the last run of the loop so that you can keep everything moving at the same speed and update like where your ball is at a constant speed. And if you just say like run it every millisecond and then assume a millisecond has passed the next time your function runs, well, you could be wrong. Maybe it's been 30 milliseconds because your computer is grinding to a halt because you're running your function too fast. So we need to find a way to have the browser kind of tell us like, when are you ready to draw something to the screen and how much time has passed? And the way we do that is with this function on the window, request animation frame. Creating a game loop in JavaScript, that's another one of those tasks that there are enough guides on, and it's kind of like a simple and specific enough question that if you just Google creating a game loop in JavaScript, you're going to find a lot of references. So I'm just going to type this out real quick. So what we've accomplished here is we've told the window, basically as soon as you are ready to draw something new, call this function again. Tell us how much time has passed, and we're going to be able to use that to figure out how far the ball should have moved at its current speed, redraw the ball, and next thing you know, it's going to look like our ball is animating around. This is a comment. I'm using it. If anything you put 2 slashes in front of, in JavaScript at least, it's going to comment out that line. It's a really great way to just kind of like keep replacing code. So we're going to comment this out for now. So now we can kind of start thinking about what is the state of our game? What are the things we want to update as time goes on, and how do we want to represent that? So one thing we're going to want to write in our state is the speed of the ball. We're going to say it moves 50 pixels per second. We're going to want to know what is the position of our ball. And we're going to say it starts at 500 pixels in its x-coordinate and 300 pixels in its y-coordinate. And we're going to write a function called update state. That is going to move the ball based off of how much time has passed. And that's all it's going to do. It's not going to do any drawing. It's not going to consider any of the other variables for now. It's great to have your functions composed to the smallest tasks you can possibly give them. It just makes your code very readable. I'm going to make sure everything is in the right units. And for now, we're just going to have the ball move to the left. Because that was our goal, just make the ball move. And it's best to focus on kind of just like proving out to yourself that you know how to do a small task and then building on top of it. Then we're going to create a function that just draws the current state of the canvas. Once the state has kind of been updated, here our only state really is ball X and ball Y. We can just redraw, and we'll see everything appear where we want it to. Let's get rid of the stuff that just kind of like draws everything dynamically, sorry, statically. Get our canvas, get our context. We're going to call a function to clear everything that was in the canvas before. Then we're just going to start drawing the stuff we already know how to draw. Here we'll draw our background. Here we will draw our ball, but instead of setting it to just 500 and 300 for its x and y coordinates, we'll pass in our state, the x and y coordinate. We'll keep the width the same, and the starting and ending radians will be the same as well. And we'll go ahead and just redraw in our paddles, even though they don't do much of anything quite yet. And then, let's see here, we still do need our event listener for DOM content loaded. So the way we're going to do that is with this. So here we'll call request animation frame the very first time, which tells window, call the game loop just as soon as you're ready. And then once it calls game loop, we call it again, which is when we tell the window, like, call it again as fast as you can. And window, add event listener, DOM, content loaded. All right, so now as soon as the document is loaded, we will call start game loop, which will request an animation frame on the window, which will call this function over and over again. And here I see already I've made a mistake because I haven't written the actual calls to our two new functions, update state and redraw canvas. We've calculated how much time passed since the last time the game loop was called. You can see here, like, this originally starts at 0, it updates over time. So this number that's passed in here is just going to grow over time. This is the amount of time that has passed since the document was originally rendered. Pass in time delta to update our state. We're going to redraw our canvas. And now let's go and see what we've accomplished. Look at that. Our ball kind of just very lazily moves to the left. Not particularly exciting, but we're getting closer. Things are moving. It looks a little bit more like a game now. That was comically slow because I doubled the size of everything, so it's doubled that speed as well. There we go. It's got a little bit more pep. Still a little slow, but, you know, I think in Pong, maybe it gradually picked up speed as you played or something. It didn't start super fast. So we've now accomplished goal number 3, make the ball move. Great. This all feels like very small incremental progress, but, you know, that's how programming works. If you try to make everything work all at once, you're going to end up with a mess. It's all about decomposing things down into like the smallest unit of progress, confirming that things work the way you expect them to, that your assumptions are correct, and then moving on to the next step. So in our case, the next step is to make the ball bounce off the walls. So we go back to our JavaScript file here. So now we're going to be introducing a little bit of a new concept, which is conditional logic. Basically, we need to say, like, if the ball is touching the left wall, start moving to the right. If the ball is touching the right wall, start moving to the left. So we need a way to run one piece of code or another piece of code depending on some piece of state. So in order to evaluate whether or not we're touching the walls, we're going to introduce, let's see here, ball radius, which is something we will use to figure out whether or not it's touching the wall. And we're going to use that right here when we draw the ball, as well as in our expression. Excuse me. We're also going to introduce canvas width here. Just a hard-coded value for now. It's great to use a constant instead of just hard-coding numbers all throughout your document. Makes it really easy to change things just once. It also makes it clear what these numbers actually are. It's generally considered a pretty important clean programming habit to get into. Might as well go ahead and implement the same thing with our height. All right. So here we're going to say, in order to figure out what we actually want to do when we update our ball, we need to determine, is it hitting the left wall? The way we're going to do that, sorry, I actually want to do this down here. So if the center point of the ball is less than the radius of the ball, is less than 15, then we know that the left edge of the ball is touching or has passed to the left the border of our left wall, because the border of our left wall exists at the coordinate 0. Likewise, we know we are hitting or have passed to the right wall if the center of our ball is greater than the width of our canvas minus our radius. And now we're going to do some things in response to that. So let's see here. I'm going to change this to absolute ball speed. So what we've done here now is create a constant and a variable. The constant speed for our version of the game is always going to stay the same, but the actual speed is going to change because it's going to move left or right. It's going to be either positive or negative. We start moving to the left just because that's what we're choosing, which means we set it to negative to start, but that will change when we hit our conditionals here. If hit left wall, here. So now that we're thinking if the ball speed is something with a positive and negative, we'll just apply the speed to the coordinate instead of subtracting it, which is what we used to do to make it move left. All right, let's go ahead and make this the speed in the horizontal dimension, just because later it will move up and down as well. So if it hits the left wall, make it positive. The speed, that is. And if the ball has hit the right wall, then the speed in the horizontal dimension will become negative. So this is how we perform our conditional logic. We pass in an expression to an if clause here. An expression is just something that evaluates to something. So this is our expression. It evaluates to a Boolean. We're passing a Boolean into this conditional. If it is true, then this line is run. Else if it's not true, but this is true, then this piece of code is run. Otherwise, neither of them are run. And this ball speed x, now that it's been changed, the next time update state is called, it will be applied with its new value, either negative or positive, to the coordinate, and we'll have essentially changed the direction of our ball. So At some point I'm going to make a mistake. I'm updating the names of variables like crazy and moving things around. At some point I'll forget to update something. That's why I'm scanning here. Let's see if I mess it up this time. What we're hoping to see is that it bounces and starts moving in the other direction. Hey, what do you know? It does. So we haven't broken something yet. I see now we are coming up a little bit towards the amount of time we wanted to spend on this. Keep going a little bit further. We're getting close. We're further than halfway, certainly. But we might not finish it entirely. In which case, that's fine. We'll just create a second video another day. Okay, so we've now accomplished another one of our goals. Make the ball bounce off the walls. Now we need to make the paddles move as we apply our keyboard input. So this is the point in which the game becomes interactive instead of just an animation of a bouncing ball moving back and forth. So this is another one of these tasks that are broken down enough that you can hit Google and just search like how to run a function in response to a key press in JavaScript, or more appropriately, probably just like detect key press in JavaScript. The browser is kind of built to detect when you're pressing buttons while the web page is in focus, meaning you've clicked it, and it's going to call a function that you can add a listener on or trigger an event you can add a listener on. If you search that, what you're going to find is a lot of examples that look kind of like this. Document.add event listener key down function event. This looks a lot like the event listener we added on the window. This is a common pattern that you're going to see in JavaScript, is adding listeners, particularly with the browser APIs. You're adding event listeners. This is telling the document, I guess, that when the key down event occurs, call this function. We need to know when the key goes up as well. So we'll add another listener. So this event is going to tell us a little bit of information about what key was pressed, basically. It's going to, for different events, it's going to have different information packaged on it. I'm going to add a quick piece of code here. This is for cross-browser compatibility. There are old versions of Internet Explorer where the event wasn't passed into the function. You have to grab it off of the window. So now when you write an event listener, I think if you want to support those browsers, you need to add that there. That's something as a web developer you end up having to do a fair amount, is making small little tweaks to your HTML or JavaScript code, doing things slightly differently to support different browsers. A lot of like frameworks will handle a lot of this stuff for you, but we're in vanilla JavaScript here, so we have to do it ourselves. So how do we know what key was pressed? We grab the key code off of the event, and then key codes are just a number, basically, that tell us what button got pressed, and there are a million websites that'll show you a graph of all the different key codes and how they line up to the different keys in the keyboard. Let me write some more state variables here real quick. We're just going to keep track if W, S, or up and down are pressed at any given moment, because that's the state that'll determine whether or not we need to move our paddles up or down. We're not doing any networking code here, so this is a version of Pong that you play with someone else using your same keyboard. It's very simple. So we're using W and S for the left paddle, up and down for the right paddle. And I happen to have the key codes right here for each of these. And now I'm just gonna like type out some boilerplate. we'll copy this into our key up function. And likewise, when the key comes up, we will update our state that these keys are now pressed. All right, so now, like we did with the ball, we need to introduce some state that will represent the kind of positions of our paddles. Right now we're just drawing them at a static position. Now that we need to move them, that no longer will suffice. So let's see here. And introduce a couple more constants here. Let's make a constant for our paddle height. We draw a paddle. Draw to that paddle height. Create a constant for our paddle width, and when we draw our paddle, we can set it to the width. Again, whenever you're writing code, having numbers in your functions is generally a little bit frowned upon. So for our left paddle origin, we'll go with our canvas height minus a paddle height by 2. They'll just have it start in the center, vertically centered. Likewise, that will create a Y origin that would be vertically centered for the right paddle. Let's create another constant here. Double that, make it a little bigger. Alright, quick refresh to make sure I haven't broken anything quite yet. Made our paddles a little bigger, centered them correctly. Alright, so now we need to update our state. For that, we're going to need to also come up with a constant for our paddle speed. Make it move about as fast as the ball, I suppose. Maybe a little faster. Make it a little easier. Keep our constants together and separate from our state here. Oh, one little fix here we will have to keep in mind. You may notice if you key code is not defined. I did mess something up here. Did I misspell key code somewhere? Here we go. Did not copy that line. When we call the request animation frame function, if our tab is in the background, it won't get called until it's in the foreground again. So you could occasionally have a time delta that is huge, and then our ball will end up like a mile off the screen before the next time this is called, and then it'll take a really long time to come back. So we're going to do a little clamping here to keep this in a reasonable size. Math is a JavaScript library that you should be able to access here. What we're going to do is make sure its minimum and maximum heights we're going to make sure its x coordinate are clamped to a minimum and maximum height. To make sure it never goes way off the screen. All right. We're also going to write a conditional for our different key presses that we're paying attention to. You'll notice a positive, negative is the only thing different here. Negative means move up, positive means move down, because our 0 y coordinate is at the top of the screen and it grows as you move down. Doing the same thing here, only difference is we're changing the right paddle, the state of the right paddle, and then we're going to do similarly some clamping logic for the paddles so that you can't just scroll your paddle way off the screen. That would be funny, but not probably great for an actual functioning Pong game. All right, let's open it up, see if it works. So I'm pressing up and down, pressing left and right. We have moving paddles. Oh, but our ball is broken. That definitely is not what we wanted to happen. Let's find out if we can figure out why. If not, you can see some live debugging. Seems like we should have hit our left wall. Certainly stopped moving. Our absolute ball speed should be 100. Oh, well, let's take a look in the debugger and find out what's happening. We can quick demo of how the debugger works. Pull this over here. Probably I'm not going to be able to get this sized up in the next few moments. Sorry if this is too tiny for anyone to read here. So, let's see here. We can pull up our console, find out what is our current ball speed. So, I think the problem is that we have maybe like an off by 1 error. We're exactly at the wrong, or at the leftmost side. So if we're at 0, 0, it says we did not, I think probably want less than or equal to there. Let's see if that fixes our issue here. If we're at 0, 0, we do want it to say we've hit left and start moving in the opposite direction. Breakpoint. There we go. We're bouncing again. Great. All right. I see I've gone quite over here. I think I'm going to wrap up the live stream for now. I'm going to call this part 1. if you followed along, you've got a cool little widget where you can move your paddles and a ball bounces around. I'm going to create a part 2 another day where you can learn how to make the ball actually bounce off the paddles, which is probably the most important part of Pong, and start getting some vertical motion with our ball bouncing as well. I think the way Pong works is if you hit the edges or towards the edges of the paddle, it kind of like adds more vertical momentum. If that'll take less than an hour, so we can add some other cool features, maybe like having the ball speed up over time, or drawing some different interesting elements onto the screen. But this, I think, will do it for now. So yeah, I hope that was helpful. That first time doing this unrehearsed, so timing wasn't quite right. Next time I will maybe rehearse and prepare a little more so I know exactly how long things will take and how much content I want to share. But uh, hopefully that gave you a little insight into how to approach building an HTML document and drawing to a canvas, and most importantly, how to decompose a task and start looking for the piece of information you need to solve it. And I guess I'll see y'all next time.